Hello, welcome to Chapter 2, Section 2.8, Solving Absolute Value Equations and Inequalities. There's going to be a lot of concepts in this section. Some of it's going to be review, some of it may be stuff that should be review that we're going to have to make sure that we remember. And there's also going to be different types of problems we're going to be doing with this. So this is a big section, so please make sure you watch all the videos, ask questions in the discussion, and be ready to go. As always, you can pause the video, rewind it, and then I will take pictures of every sheet of paper that I'm going to use so you can go through those on your own time if there's a question about something. So let's get started. We're going to first introduce a couple of vocabulary words. We're going to be using the words or and and. And if I have a compound statement, which you can read right there, it's more than one equation or more than one inequality. You're going to see that coming up. If I have a compound statement that uses the word or, we call that a disjunction. And if I use the word and, it's a conjunction. So for a lot of these problems, we're going to ask, is it a disjunction, is it a conjunction, and how does that help us solve? But first, before we get into that, we need to talk about the word or actually the words or and the words and. So think of this situation, right? This is called the Venn diagram. I know the English teachers use this, but it's actually a math idea. So let's say that I have a situation to where maybe there's a class, okay? And in this class there are some 9th graders and some 10th graders. So just for the purpose of the class, no 11th or 12th graders, anyone other than 9th and 10th graders, okay? And let's say that we have some people who play sports in the high school, and there's some of them that are not doing sports. That doesn't necessarily mean that they're not involved somehow. Maybe they're in clubs, but we're just focusing on whether they participate in a high school sport. They're on the football team or cross country team or whatever, or whether they're not. Okay? So if I had really annoyed our custodial staff, and if I painted big circles in the gym floor, and I took my class down there and said, if you are a 9th grader, stand in this circle. And if you are also participating in sports, stand in this circle. So every student in that class should figure out where they are going to stand. So in this section over here, these are 9th graders that do not play sports. In this section over here, these are 10th graders, or people who are not 9th graders, who do play sports. And in this middle part right here, that's going to be the 9th graders who do play sports. Now, the people who get left out, which would be the people who are not 9th graders, the 10th graders, and the people who do not play sports, are going to be standing on the outside of the circle. So if I say the word or, if I said, all right, now I want you to raise your hand, or call out or whatever it is, if you are 9th grade or you play sports, and I'm just gonna label these, okay? So I'm gonna label this Group A, Group B, Group C, and Group D. So remember, A, it's easier if I do it that way. A is going to be the 9th graders who are not in this circle, so they don't play sports. B is going to be the 9th graders that are in both circles, so 9th graders who play sports. C will be the students who play sports but they're not 9th graders. And D will be the students that are not 9th graders and they're not playing sports. So if I said, all right, raise your hand if you are 9th grade or you play sports. The people who are standing in A are going to raise their hand because they're 9th graders. The people that are standing in C are going to raise their hand because they play sports. And the people that are standing in section B are going to raise their hand because they're both. All you have to do is be at least one, okay? So for this one, at least one has to be true. Now, if I said, okay, this entire group, if you are a ninth grader or you play sports, I want you to, go report to Mr. Arn or something, I don't know. That's what we actually call the union. So we'll connect that. In later classes, you'll spend a little bit more time talking about set theory. We kind of introduce it here, and to be honest, I have a lot more fun doing this in class, but this is the best I'm going to be able to do with the video. Okay? Now, a compound statement that uses the word and, we call it a conjunction. This would be a disjunction with the word or, and at least one of them has to be true. So it could be this one could be true, it could be that one that could be true, and when I say at least, if I have more than one, that's okay also. If I switch over and start talking about the word and, if I said raise your hand if you are a ninth grader and you play sports, the people in A are not going to raise their hand. They are ninth graders, but they don't play sports. The people in C are not going to raise their hand. They do sports, but they're not ninth graders. And the people standing outside in this section D on the outside, they're neither, so they're not going to raise their hand. The only people that are going to raise their hand is this right here in section B. So in other words, both have to be true. And like I said, this is something that I really try to spend a little bit more time with when we're together in class. So this could get a little confusing. And then that way we try to try to have fun with it and everything. Raise your hand if you were a ninth grader, that kind of stuff. So we try to get the idea of ands and ors. This up here was called union. This is called the intersection. And by the way, the symbol for union looks like this. The symbol for intersection looks like this. If you read the book, they actually kind of talk about that, but they don't really go too deep into it. So I wanted to mention it in case you saw it. If any of you, and I know we offer some programming classes at Highland Park Senior High, but there's also some of you may have actually learned this stuff on your own. Okay, you may use the words and or. Of course, I wrote them backwards in the way I said it, but that doesn't matter. We may use the words and or in programming, where you're talking about a test for a condition, and if as you input some variables in your program, you'll test those variables, and if you write it in a way that or is the operator, then at least one of them has to be true, and it'll say do this. But if you write it in the way that it's and, then both of them have to be true. These are actually called Boolean algebras. A little bit of trivia. There's a whole branch of math called Boolean algebra. Can you guys even see that? Sorry. And I think his name is James Boole. Okay, but there's a lot of information that went into this, and it involves set theory, and of course this is a Venn diagram. I think it was John Venn. I always forget whether it's James Boolean or John Boolean or James Venn or John Venn. Should have looked that up before I started to make the video, but it's one of those things that's really not that important. But this idea of ors and ands, it's used in programming, but it's also used in philosophy, and it's used in understanding how the nature of things work. So it's actually really kind of cool. How does that help with what we're going to be doing with this section of algebra, though? Okay, so let's do a couple problems. So I'm going to have a compound inequality, and the inequalities we have is going to be, I could have less than or greater than. This happens to be less than or equal to also, and when we graph it, we'll show you what that means. For the first one, we have the word or. So like I said on this sheet, when I use the word or, at least one of them has to be true. So if I'm going to solve this together as a compound inequality, if any x makes this true, it's going to make the entire thing true. And if any x makes this one true, it's going to make the entire thing true. When I get down to the x's that make this true also have to be the x's that make this true to make the whole thing true. So again, it could be this or this, but down here where I use the word and, it has to be both. Okay? So how do we go about the process of solving this compound inequality? Well, we solve just like an equation, and that's one of the things that we review when we're normally in class, and unfortunately we aren't going to be able to do that for the videos. But I will put together something to have you review this. But it's an Algebra 1 skill that I know you guys pick up in maybe in like even pre-algebra. So you treat the inequality just like an equal sign, except for one thing, and it's going to occur right here, and I'll mention it when we get right there. All right? So first we're going to do this. We're going to do x plus 3 is less than or equal to 2. To solve for x, I'm going to do the opposite of what's happening to it. So I'm adding 3, so I'm going to subtract 3 or add negative 3 to both sides. I like to draw a summation bar here. 3 plus negative 3 is 0, so I just get x plus 0. And 2 minus 3 is negative 1. Excuse me. 3x is greater than 9. I'm multiplying the x by 3, so I'm going to divide by 3 using a fraction bar, horizontal fraction bar. I'm not going to use the obelus. The obelus is this thing. Don't use that. 3 divided by 3 is 1. 1 times x is x. 9 divided by 3 equals 3. So I know that my x's that make this entire thing true are going to be the x's that make this true, or they're going to make this true. I'm going to use that word or again now that I've solved it. How am I going to graph this? Well, I'm going to draw a number line, and in the middle, even though it's infinite, I'm just going to in the middle what I've drawn. I'm going to write 0. This will be 1, 2, 3, 4. Maybe I got room for 5 there. Negative 1, negative 2, negative 3, negative 4. So I'm going to graph both of these. X is less than or equal to negative 1. Since this also could be equal, I'm going to make a point on negative 1. And all of the numbers that are less than negative 1 are going to get included. So I draw it like that. X is greater than 3. I go to 3, but 3 cannot be greater than itself. This doesn't have the or equal to. So that way I put an open circle. I don't fill it in. And I want the numbers that are bigger than 3. So I draw like this. Now, one thing that I really want to stop. I do not want you to do this. So I won't draw all of them in, but here's negative 1 and 2, 3. Here's 3. Do not do this. All right? Don't draw above the line. I know why some teachers do it that way. It's a bad way of doing it. It's a violation of what we call the ruler postulate. I need you to know that each of these points on this line, this is a geometric line. Okay, has a width of 0 and it has an infinite number of points, and it goes both directions in an infinite amount, and it pairs up with the number line. So each point on the line is paired up with a real number. So that's why we're actually graphing on the number line. Okay, so make sure that you don't draw anything like this right here. Don't do that. So this is my solution, and that's my graph of the solution set, and any number that's graphed here is going to solve this. All right, now let's switch it up. Let's do the other one with the and. This was, oh, by the way, this was a disjunction using the word or. This one is going to be a conjunction. And you're going to see why we call it disjunction conjunction in just a moment when I draw the graph. So same thing, I'm going to do negative 2x is less than 8. I'm multiplying the x by negative 2, so I'm going to divide both sides by negative 2. But I mentioned just a couple moments ago that I have to remember something when I do this. Remember that when you multiply or divide by a negative, the sign is going to switch. So x is greater than negative 4. Excuse me. The other one, I get x subtract 3 is less than or equal to 2. I'm going to add 3 to both sides. That does not change the sign. And I get x plus 0 is less than or equal to 5. And the word and is still here. I just didn't give myself enough space for it. Okay, so let's graph that. Here's 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Negative 5 right there. Okay? I just labeled the 5 and the negative 5. They're all there. And remember, every number is here on my number line. So x is greater than negative 4. It cannot be equal to negative 4, so I'm going to put an open circle at negative 4. And I'm going to start graphing to the right. But I'm going to pause for a second because I don't know how far to go. Over here I've got x is less than or equal to positive 5. Since it could be equal to positive 5, I'm going to fill in my circle. And I'm going to continue this between these two. So a disjunction using the word or goes this way. A conjunction using the word and goes this way. And since I'm using the word and, both of them have to be true. So if I said over here, for example, I've got 7, I know that 7 is greater than negative 4. But it's not graphed because 7 is not less than 5 or equal to 5. So I don't graph 7. I only graph the numbers that make both of these true. So I start at negative 4, I go up to 5, and I stop. It's just this part that's between the 2 points. So disjunctions with the word or split, conjunctions come together. I know this video is going to be a little bit longer as I introduce some things, but I'm going to do a couple more problems. And I'll pick up the speed just a little bit. All right? So this one has the word or. It is a disjunction. I might just start abbreviating. We'll see. X plus 3 is greater than 7. I'm going to subtract 3 from both sides. And I get x is greater than 4. I also get 3x is greater than 18. I'm going to divide both sides by 3 using my fraction, not my oblus. And when I divide by a positive, that does not affect the sign. So I get x is greater than or equal to 6. So now let's draw that graph. We'll say 0's right there. 1, 2, 3, 4, 5, 6, 7, 8. All right, now, if I do x is greater than or equal to 6, I'm going to fill in the 6 right here, and I'm going to go to the right. If I do x is greater than 4, I'm going to start at 4, and I'm going to go to the right. So notice that this part is not necessary, because every number that is greater than or equal to 6 is already going to be greater than 4. So since both these are basically pointing in the same direction, I only have to worry about where it's going to start and then just go that one direction. Next one. This is or, so it's a disjunction. Dis. I get x subtract 2 is less than 1. I'm going to add 2 to both sides and get x is less than 3. 5x is greater than or equal to 30. I'm going to divide both sides by 5 and get x is greater than or equal to 6. And I did not switch the sign because I'm not multiplying or dividing by a negative number. And of course I wrote the word or. I forgot to write or up here too. I'll do that for the picture. Alright, so on my graph, let's say 0, 1, 2, 3, 4, 5, 6. I'm going to do x is less than 3, open circle on 3, and I'm going to go to the left. X is greater than or equal to 6. I'm going to fill in my circle on 6. Maybe I should have drawn my line a little bit longer, but that's okay. And it's going to go to the right. Finally for this video, I'll do more examples when I get to the guided practice problems, but finally for this example, I get 2x is greater than or equal to negative 6. Oh, excuse me, the word is and, so that is a conjunction with an N. This is why you don't use markers, guys. I'm going to divide both sides by 2, again using my fraction, not an oblus, and I get x is greater than or equal to negative 3. Now if you're wondering why I did not switch the sign, that's because I have a negative divided by a positive. It's only when you multiply or divide by a negative that you're going to switch the sign. A negative divided by positive, I'm going to leave it alone. And negative x is greater than negative 4. In this case, think of it this way. Negative 1 times x is greater than negative 4, and I'm going to divide by negative 1. In this case, I am going to switch the sign, and I get x is less than positive 4. So to draw my graph, I've got, make sure I drew my graph big enough. We'll do negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. There's 4. All right, so I'm going to start at negative 3, and I'm going to fill it in, because negative 3 works, and I'm going to go this direction. But before I draw any more, I want to find out where the other boundary is. It's at 4 with an open circle, and it goes this direction. Okay, so that's a lot of information in a 22-minute video. Ask your questions in the discussion and do your best with the homework. We'll see you in the next video.